Shouts to the one above for giving me another day. Graham still watching. See, I'm on my way to make it to that other stage in this game I started to play.
Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
This is the concept video for approximations and local linearity. So, let's say we have some function f of x and let's say we know the value of f at some x0. So we know f of x0. But let's say we want to find f of c. Example of this would be, let's say our function is x to the third, and that's not, I know it doesn't look like x to the third, but we know, for example, f of 2 is 2 to the third, which is 8, but calculating f of 2.1 is a bit more of a complicated task. So we're not going to find the exact value of this. And this is useful for sines and cosines and exponentials and logs, where it isn't as easy to find do the computation by hand as it is for cubing. Anyway, what we're going to do is we're going to construct what we call tangent line, and instead of, and then we're going to call this, and let me label some of these things. This is f of x. We're going to call this tangent line capital L of x, and instead of finding f of 2.1 or f of c, we'll find L of c. So L of c should be approximately equal to f of c. As we can see in this picture, it's only a little bit of an overestimate. So the way we do this is, well, we know that the equation for a line equation for this tangent line, we know that it should be y minus y0 equals m times x minus x0, where x0, y0 is a point on the line, a point, and m is the slope of the line. So in this case, our point on the line is x0 and f of x0. So we can plug in f of x0, and we already have x0. So next thing to do is look at the slope of this line. Let me go to this example. So we look at the slope of this line, and the slope of the line is f prime of x0. So the equation for our tangent line becomes y minus f of x0 equals f prime of x0 times x minus x0. So solving for y, we get y equals f of x0 plus f prime of x0 times x minus x0. And since this y is approximately, we'll call this L of x instead of our new function L of x. So this is the local linear approximation, or the linearization of f of x, and we can write that f of x is approximately equal to L of x. So f of x is approximately equal to f of x0 plus f prime of x0 times x minus x0. And this is the local linear approximation for f. And going back to our example, we're trying to approximate f of 2.1. Well, f of 2.1 is approximately, if we use x0 as 2, it's going to be approximately f of 2 plus f prime of 2. And remember, for this example, f of x is x to the third. We have x minus 2. So we know f of 2 is 8 because it's 2 cubed. And f prime of x is 3x squared. So f prime of 2 is going to be 3 times 4, which is 12. So 12 times x minus 2. And, actually, this is just f of x right now. Now if we want to find f of 2.1, we plug in 2.1 into this. This gives us 1.2 times 0.1. It's 8. This is 12. Now it's 8 plus 0.2, which is 9.2. 2.1 cubed is approximately 9.2.
Got a game, feels good to do what I love after I wake. First nourish the soul and let the art take place. Word, for her I know my heart made space.